Hello everyone, welcome back to Let's Embark. Yes, we are in 8th subtopic of Unit 2, 2.8 inverse functions. So it's a very important but simple key concept of inverse functions. And we already learned exponential functions and we have started from the laws, function, how it behaves, everything, right? Now, after this inverse function, we will learn a new function which is inverse of our exponential. And yes, let's understand what is basically inverse function here is. So an inverse function is a reverse effect of a function. So if your function is doing something, your inverse function will undo that. It's kind of that. So if f of x is a function, its inverse will be denoted by f uh, power. In the power, you can say minus 1. Actually, it's not power, but the way we write. Okay. Inverse of x satisfies f of f inverse of x. So what is this conversion, right? So f, actually the original function and its inverse. If you composite, you will get the x, the input, right? So, and also the reverse way. So f inverse, you composite with f. This way also you should get the x. Okay, so basically it undo. If you take a square root, if your f is taking square root, and what is f inverse? You just squared it. So root x square will give back the x. So this is the process of f inverse, and this is how the inverse function will work, right? And now let's. So how to find an inverse algebraically? So now I said root x means the inverse is x square. But it's not that simple. There is some important criteria we should check on. So analytically, if you give an equation kind of function, y equal to f of x. Okay, so like f of x is equal to some function x square plus 5x, something like this. First thing, you should replace your f of x with y, like y equal to in terms of x. Then swap x and y. For example, this is y equal to x square plus 5x. Swapping means all x will turn to y, all y will turn to x. So I will get x is equal to y square plus 5y. Now solve for y or make y as a subject. Now again I will make y in terms of y as a subject. Okay. So now replace y with f inverse of x. Then we will have something like in terms of x, we will have this side. So y equal to f inverse. Okay. So this is how we will do. But still, let's understand. This is the analytical process. Let's understand the graphical process. So this is a basic quadratic y equal to x squared. Finding inverse graphically means we all know the line, the diagonal line y is equal to x, right? So draw the line y equal to x. Okay, let me zoom. Okay, we are drawing the line y equal to x here. Okay. And you reflect it, we know the reflection, right? And you're reflecting the original y equal to x square with respect across the line y equal to x, and we got this orange color parabola. Again, it's a parabola, but it looks different. But we know very well the original parabola is a function. But what do you think? Is this a parabola? No. Sorry, actually, is this a parabola? But is it a function? No. Why? Because it doesn't pass the vertical line test. But to say it's an inverse function, it should be a function first, correct? I did the inverse process, but I didn't get a function. So what should I do? The double branch is the problem. That's why your vertical line, when it passes, it gives two values at a time, correct? So I have to cut one branch. Maybe mostly we'll take the right branch, the positive side. So here I cut the branch. If you cut here, you have to cut this also, correct? In your original function also. In your OG function, we need to restrict the domain for inverse function to be exist perfectly. So restrict domain of OG function so that inverse will act as a function. So I cut this. I didn't take x less than 0 in the parabola case. Now if you remove this part and you reflect, yes, I got a function. This is a function. It will obey the vertical line test, right? That's why we learned square root of a number means you can't put negative there, right? Square root of -5 is not possible. We might have learned that this is the reason. And this is how we restrict the OG function so that our inverse function will act as a function. Otherwise, it will have some trouble, right? And here we are moving to the next part. Now, what is this? There is a technical key term called one-to-one function. So we can understand like y equal to x square is a good function, but its inverse have a problem. We need to restrict it. But so what kind of, but when you reflect a line, right? This is a blue line, you can see. When you reflect it over, like if you try to find inverse, no restriction on the line. It will beautifully give you an inverse, no problem. But parabola doesn't do. So there is a one thing here, a function which have a special name one-to-one function. A one-to-one function where each input has a unique output. So 5 is goes to 3, 6 goes to like 5 goes to 25, 6 goes to there is like something like this. Every input should go to one and only output. And each input also corresponds to exactly like perfect one number to one place. But we learned in function 5 can go to 6, 10 also can go to 6, 11 also can go to 6. Okay, it's function. But in your one-to-one function, no, not like that. 5 goes to 6 means next 10 will go to something different. 7, 11 will go to 8, 1 to 1. Okay. So, and every one-to-one function will pass the test called horizontal line test. Okay. How to check the one-to-one function or not graphically? You have to draw a horizontal line, a line parallel to y-axis, and you pass it through your function. If it cuts more than once, then it is not a one-to-one function. We need domain restriction there. Okay, but when you pass this horizontal line to the line, yes, it's one-to-one throughout. It maintains one crossing, correct? So vertical line test is just for checking a function. If it's one-to-one or not, we need to check the horizontal line test. Okay. So graphing inverse function is you graph your original function, reflect it over the line x. What is reflecting? If I have this function here, every point or vertex, some common points you will do. So this vertex you reflected, you got it here, right? And this some mandatory points you can pick and you reflect it. It will be here, something like this. This is a reflection. So key points only will do and check the domain and range. So is after inversing that, do you get a function? Is it a function? If not, restrict your domain and check your range. And that's it. So we can do a decent sketch. Okay, vertical line test, as I told you about, it's just for a checking whether it's a function or not. So OG function will be function for sure, but after the reflection, apply vertical line test. If it's not obeying vertical line test, then we need to restrict it. Okay, we know this already. So now, horizontal line test is for checking one-to-one function or not. If it's one-to-one, then it has an inverse. Okay, if it's not one-to-one, try to restrict domain and find an inverse. So you have, as I mentioned already in a problem, so you have to pass a horizontal line through a graph. So in this case, we know this is horizontal line. Parabola, it's cutting more than 2 points. Circle also. Only this line is a one-to-one function. Others are not one-to-one in this case. Right? And now, let's go for question. Find the inverse of function and state its domain and range. So first you should write y equal to x form. Okay. So y equal to x minus 3 the whole square plus 1. And you need to swap x and y. Okay. So I will get x is equal to y minus 3 the whole square plus 1. Now you need to make y as a subject. So subtract 1 on both sides. X minus 1 equal to y minus 3 the whole square. And when you take square root, you should do plus or minus. Then square root of x minus 1, here y minus 3. And finally, we got this. This y equal to 3 plus or minus square root of x minus 1. Two equations, two branches we got. So y equal to 3 plus square root of x minus 1 is your right branch. Okay, maybe you can take one and mention that because if you take both, it will not be an inverse function. So any one you can pick. Generally, you will take positive right, that upper branch, something like that. So this is a right branch. And how to state domain and range? So it's a square root function. Under the square root, only 0 or positives alone, no negative. So your x minus 1 should be greater than or equal to 0. Then what is x? X greater than or equal to 1. That's it. So your domain is any number which is greater than 1 until infinity. Okay, then coming to range. How can I find range? Let's do here. So it's my function y equal to 3 plus square root of x minus 1. What square root of x function will be something like this. Its range will be only positive. Okay, OG square root x function, um, okay, will have a positive. So how can we proceed in finding this complicated stuff? Means, I know x is greater than or equal to 1. Then what is x minus 1? You subtract 1 on both sides, x minus 1 greater than or equal to 0. If you square root it, square root of x minus 1 greater than or equal to 0. Then you add 3. I'm trying to make the entire equation. So I made it. So you will add 3 on both sides. So 3 plus x root x minus 1, you can write it as y greater. It's the range. So range is greater than or equal to 3, which is 3 comma infinity in interpolation. Right? So this is how we will find domain and range. And moving to question number 2. Using table, find f of 2, f of 7, f inverse 5, f inverse 8, f of 5, okay, out. Okay, f of 2 is simple. When x is 2, it crosses what is this? Is f of 2, right? So it's 5. And when f of 7 means when your x is 7, what is the relatable f of x? So it's 4. Super. Then f inverse of 5. What is f inverse of 5? Swapping, right? In reflection, xy will go, xy is OG means yx is the inverse function. Okay, so now in inverse, this will act as x. This x will become f inverse of x. So if you want f inverse 5, here you have to check 5 and what does it produce? Okay, f inverse of 5 is 2. Then f inverse of 8 is, go for 8 and 6. Then f of 5 is, okay, let me do it here. F of 5 is 6. Okay, you can see one thing. F of 2 is 5. F inverse of 5 is 2. Correct? F of 2 is 5. Like f, if you shift here, 2 equal to f inverse 5, we got this relation, inverse and OG relation. Okay. Now coming to the last part, what is f inverse of 16? So f inverse of 16 is, here you should get, this is your x as of now. 16, I can't find 16, so it's undefined in this table or in this function. Right? So this is my simple inverse function in tabulation form. Now, last question. The graph of the piecewise linear function is shown in the figure. Let g be the inverse of f. What is the maximum value of g? Okay, how can we sketch the inverse? Sometimes they will ask you to sketch the inverse function also. So I'm going to show you sketching the function and then finding max. Okay, so sketching is simple. Let me start from leftmost of your graph. It's minus 3, minus 2. Okay, then your inverse will have the swapping that minus 2 and positive 3. X is minus 2, y is, sorry, minus 2 and minus 3. Just swapping. So it reflected here. Actually, you can draw y equal to x, but we are not doing that. Okay, y equal to x. Okay, this is the first point, and a let it be. Then I'm gonna do this. Minus 2, 0, correct? So when you swap this, 0 minus 2, x is 0, y is minus 2. So here it is. Okay, let me maintain same color, B. Then here, this is 0, 2, and it will flip into 2, 0, 2, 0 here. Okay, then why I'm writing ABC means I should correct in order. Okay, that's fine. And this is 2, 3, right? So 2, 3 will flip into 3, 2. So here, D. And last one, this is the last one, which is 3, 1, and it will go 1, 3. X is 1, Y is 3. Okay, let me erase them all at once. And green points are my points, and I can start graphing them A to B, B to C, C to D, then the last one. This is how it will be reflected. If you draw the line y equal to x diagonal, it's not perfectly done, but you can draw it. So you can sketch in that way too. Okay, what is the maximum of the OG graph? So maximum of f is the peak point, the top one is 3, I think. And maximum of G, that's your inverse is also, that is also 3, correct? So in this case, inverse and OG function have 3 as the maximum. Okay, so this way we can find the maximum. So without sketching also we can find, just swap your x coordinates and y coordinates. And in your new y coordinates, after swapping, which has maximum value, that is your maximum of the function. Okay, so, and that's it. Here we have a bonus question. A temperature sensor outputs a voltage based on the ambient temperature. The voltage is modeled by this equation. Find inverse. Interpret the meaning of inverse in the context. What temperature does the voltage of 6 volts corresponds to? Simple but effective. So do solve the problem and drop your answer in comments. Also, you can comment your suggestions and feedbacks to us. So we would love to help you. With this, we are wrapping the video. You're doing great. So if you want to watch more contents like this, do subscribe for Let's and More. And we have many playlists there for you for AP Calculus and many other math curriculums. So that's it for today. Keep learning, keep practicing. If you want to join student community of Let's and More, here you can scan the QR code. Thank you. Stay curious.